Hello, welcome back. In this segment, I will introduce you to the GNU cflow tool. You can look at the call graph from a given C program. You can look at which variable being used by which function, cross reference of symbols. Those are the two main use cases of cflow. cflow itself is a GNU tool. You could download it from the GNU site. For example, if you go to gnu.org, you will be able to download cflow. So my plan for this session is to show you how to use cflow. I'm not going to be complete in terms of all the features, but I'll give you the core of it. Yeah. So I'll take a simple program first, which is part of the cflow doc. You go to the doc folder after you install. So if you just type cflow doc, who am I? It's going to show you a call graph. Okay. You can add some details. Suppose you would like to see it in a better format. You could put minus tree. It will perform some indentation. Main is calling printf, fprintf, and main is also calling who am I. Who am I is calling all these functions. You can see here main is defined in whoami.c file. Okay, and whoami itself is defined, and the underscore whoami is defined in whoami.c line number 8. So if the definition is available, it is able to show you where it is defined. Okay, suppose you don't like to see the arguments, okay, to make the graph simple to look at. So what you can do is you can just say omit arguments. Will get rid of arguments, like you don't see the details that are passed to the main function, like int argc, char pointer. Interestingly, it is not parsing the header file. We will talk about C preprocessing later. I just wanted to tell you that if you look at this, right, it's not opening all of these header files and extracting symbols and things like that. It's just ignoring them more or less. Okay, if you wanted to do C preprocessing, we can explicitly tell that do preprocessing so that it knows the types and so on. Okay, it can be a good thing because if you're analyzing some system for which you don't have all the header files, you can still work with this. Yeah, I'm going to show it in the dot format for this example they gave. Pipe it to the dotty tool, which is like a graph viz tool that you download separately. Okay, and now you can see a graph. This graph shows main is calling who am I, main is also calling printf, and who am I is calling all these functions. Okay, we don't know from the graph the order in which these functions are called. As soon as you visualize the graph, you don't have the order. Okay, so suppose you're analyzing a library and there is no notion of a main. Okay, that means you need to tell the cflow tool where to start the analysis. Okay, which you can easily do with minus main option. Okay, let's take an example. Suppose we don't want to start from main and our main is pretend to be, say, who am I? What we can do is simply go to the cflow, right? Just say minus main, who am I? And the example program. And now you see here, the who am I becomes your entry point to your analysis, and you get the call graph starting from there. I think this is pretty neat that you could define which main function, and you can have multiple main functions. By the way, it's not just only one main function, although I'm just showing you who am I as the main function. All right. So let's analyze this. Clear. This is perhaps better. Let me get rid of the arguments because they make the graph difficult to read. As you can see, main is the entry point. It's calling the counter, and main is also calling report. Counter is calling several functions, and then next layer. You can define how many layers you wanted to see using the depth option, d.c. Yeah, it has, let's see, it has static global variable, right? This is a static global variable, and it has global variable. And in case you are interested in analyzing how the global variables are used, where are they referenced, you can do that also in cflow. So all you have to do is you do cflow, right? Minus I include references to symbols, right? And just say doc d.c, for example. That's the program that we want to analyze. And we get rid of arguments, and we wanted to put it in the dot format, right? We should be able to see it now. Dot minus txlib. Main function, this is regular function call, but look at this. There is int max level, which is a variable. So it's showing main is using this variable. And it seems like there is also a dependency to that variable from print director. Okay. And there is a recursive call from print dir calling itself. That's the reason you have a self loop. And you can also see there is a dependency to the global variable ignored names, static variable. You can also filter out static variables, by the way. I will show you next very quickly. Ignore, yeah. Okay, static variable. You can see the static variable is gone. The graph is much smaller now. We got rid of the static variable. Okay, so we can filter out things we don't like. It has much more arguments built inside. You can specify, ignore certain symbols. If you wanted to have type defs shown, you can also ask it to show type defs and those details. Okay. One more thing I wanted to show to you is, suppose you have multiple files, okay, and you would like to see dependency between files. You can also do that. I built some small programs to show you that. I have this file foo.c, which contains foo as a function. It's goo. And the goo itself is not defined there, right? But it's defined here in another file called goo.c. Okay. Does it analyze these multiple files code? Yes, it does. I can just say foo.c, goo.c, and it was able to show me this. And we can definitely do the same with whatever we did with graph visualization, right? You could say, show me foo.c and goo.c, analyze the graph. You should be able to see it. Yeah, very simple now. But look at this. It's able to show you who is defined in foo.c, goo is defined in goo.c. So it was able to connect the definition also with the symbol reference. Okay. So multiple files can also be analyzed using this cflow tool. The cflow can also be integrated into make files and so on. I'm not talking about it today. In the next segment, I will show you how to configure the cflow for, pre-processing in particular. Suppose you wanted to analyze symbols that are defined inside header files, you can use pre-processing related ones. Suppose you're missing some header files in your analysis, you can artificially define symbols outside in the command line as well, which is something I will discuss in the later segments. All right, thank you very much for your attention.